Right, grade 12. So this is going to be lesson 7, and we'll be focusing on stationary point or points of a function. And this is in page 103. Then you're just going to write the date of the 26th of May. Now, remember, stationary points are basically a turning points on your function, right? So now, in this point, we are dealing strictly with cubic graphs, and your cubic graphs basically have two turning points. So meaning that if you have to calculate the stationary points, it's going to be those 2 points, right? Now it says that in order to calculate the stationary point or points of a function of f, right? First, we have to ensure that we find the derivative of f, or f prime x, and that derivative is equals to 0, right? With intentions of what? With the intentions of solving for x, meaning that we need to find those two coordinates of x on our graph, right? So now if you can just look at this small sketch here. So now if you can look at this sketch, you can see that your graph has two turning points, right? These two turning points are basically stationary points, and it has the first x value and the second x value, right? So meaning that in order to determine the stationary points, we have to find the derivative of what? Of f first, which is equals to 0. Then from there, we solve the values of x. We need to determine the values of x. After getting the values of x, we know that x lies on the graph of f, right? It means that to find y, we just have to substitute the value of x in our function in order to do what? In order to get what? The value of y, right? So now, but let's just go through this so I can explain what is happening here. Right. So it says that you're going to let f of x be equals to 0. I mean, the derivative of f be equals to 0 and solve for x, right? And step 2, you have to use the original function f of x to determine the y value, right? So meaning that with this one, you just have to substitute the values that you have determined um, in order to substitute them and find the values of y, right? So now remember, for stationary points or point, yeah, the derivative of f of x with respect to x is equals to 0. Now let's look at this example. So it says that the sketch alongside shows the graph of f of x, which is equals to minus x to the power 3 plus 6x squared minus 9x plus 3x, right? So now this is going to be our function, right? So this is our function, and our function is represented by this equation, right? Now it says that calculate the coordinates of the stationary points. So this is stationary points. Sorry about that. So these are stationary points of f, right? Remember, stationary points is represented by what? Finding the derivative of f of x is equals to 0. Then for b, it says for which values of x is f increasing and decreasing, right? So we'll go to that as well. So now for here, let's start with a. It says calculate the coordinates of the stationary points of f. So it means that what do we have? We have our equation, which is equals to, so this is going to be f of x is equals to minus x to the power 3 plus 6x squared minus 9x plus 3. Right. Then if you have to find the derivative of f, this is going to be minus 3x squared plus 12x minus 9, right? Because now we have to determine the x values of the stationary points, the derivative of f of x is equals to 0, right? So, but we know that it's equals to 0. Therefore, we're going to have derivative of f of x is equals to negative 3x squared plus 12x minus 9 is equals to 0. Then from there, we know that we have negative 3 as our highest common factor. So we're going to have minus 3. So this is going to be x squared. Then this is going to be minus 4x. And then we're going to have positive 3, right? Then when you divide both sides by negative 3, we're going to get x squared minus 4x plus 3 is equals to 0. Then from there, you're just going to factorize. So you're going to factorize. Then we have the factors of 3. So we have negative and negative. Then the factors of 3 is going to be 1 and 3 because 3 is a prime number. So, but at the end, it's going to give us what? Negative 3 and negative 1. It's going to give us negative 4. So meaning that the x values is going to be 3 and 1, right? So meaning that from here, it means that from this graph, the x values is going to be 1 and 3, right? So meaning that 1 and 3, these are the x values of our turning point or stationary point, right? So now we know that if x is equals to 3 here, we just have to substitute 3 on the function to find the position of y. And also we have to substitute 1 on the function in order to find what? To find the y value, right? So now if you can check, so this is what we have. So it means that for f of 1, we have negative, so it's going to be 1 to the power 3, then it's going to be 1 squared minus 9, then plus 3. So this is going to give us this is going to be power 3, then we have plus 6 minus 9 plus 3. So this is going to give us negative 1, right? So meaning that for the stationary point, we're going to have when x is 1, y is going to be minus 1, right? Then when f is 3, then we're going to have negative 3 squared 6 multiplied by 3 to the power squared minus 9 multiplied by 3, then plus 3. Then this is going to give us a final answer of 3 right? So meaning that when stationary point, when x is 3, y is equals to 3. So meaning that here we know that if x is 1, y is going to be minus 1. And if x is 3, y is also going to be 3. So these are the two coordinates. So meaning that we have 1 and 1, negative 1 and 3, right? Then let's look at B. So B says, for which values of x is f increasing, right? So now let's look at the graph. Let me just remove this option here, right? So let's look at the graph. If you can check, here we have 1 and here we have 3, right? So now basically we're focusing on our x-intercept. Now looking at the graph of f, right? We can see that there is the behavior of the graph is decreasing here from negative infinity to 1. And also from 1 to 3, there is an increase, right? Then after that we have a decrease. So meaning that this is a decrease, this is an increase, and this is a decrease. But now they ask, for which values of x is f increasing? So it's increasing way. Looking at your x-intercepts, we can see that of your turning points, you can see that our graph is increasing from 1 to 3, right? We're basically focusing on the x values, right? So meaning that between 1 and 3, right? This is where the graph is increasing, right? It's between this part here from 1 to 3. This is where it's increasing, right? It's increasing. And also, if you have to write it in interval notation, this can be an x as an element between 1 and 3, right? Then for number 2, it says that for which values of x is f decreasing? So meaning that where is x decreasing, right? So meaning that what is happening to x? X is becoming less at 1 and it is becoming great at 3, right? Remember, we're focusing on this part. It's decreasing from where? From 3 to negative infinity and decreasing from negative infinity to 1. So meaning that for B, so x, what is happening? X is decreasing, so it's going to be less than 1, or x is decreasing way. It's decreasing at 3, so it's becoming great, so it's going to be greater than 3. Or we can just say x is an element from negative infinity to 1, or from 3 to infinity, right? So it's either you do it in set or interval, then that's how you do it. So remember, when you're talking about interval notation, you just have to work with your turning points. That's where you have to establish the pattern on whether does it increase or decrease. So this is going to be the end of the lesson. Then from there, I'm just going to give you a work for exercise 6.